Simulation tools fall into several categories. Since people are often unaware of the differences among the tools or even the existence of some of them, we'll briefly explain the major categories. Note that not all simulation tools offer virtual commissioning capabilities, but it's useful to know what simulation tools are available that may help you to improve your processes. Kinematic tools like Siemens Kinematic's RobCAD and Process Simulate Robotics let you perform offline programming, analyze the real-time motion of robotic work cells, optimize cycle times, optimize welding sequences, and increase process quality. It even added spray painting simulation capabilities recently. The next slide is a short but sweet video showing Process Simulate modeling robotic stations in an automotive body shop. Notice that it's very detailed down to the clamps. Another category is ergonomic tools like Jack and Process Simulate Human that let you analyze human motion and optimize the ergonomics of human operation to enhance worker efficiency and minimize injuries. Note that the focus here is on the actual motions that a worker makes in order to complete a task. Computer-aided engineering tools like WINCC has a suite of tools like Mechatronics Concept Designer and Sim Center that let you analyze specialized items like thermal and flow analysis and finite element analysis early in the design process. There are numerous features here like designing flexible wire harnesses, additive manufacturing products, and acoustic simulations. You can even hear the simulated sound of a machine running that you've designed. The result is better performing products and machines. Computer-aided manufacturing tools like NX-CAM let you analyze specialized items like tool design, NC programming, feature-based machining, and collision detection. This automates the development of molds, dies, and fixtures for higher quality, lower cost, and faster turnaround for machining. Pedestrian flow tools like Pedestrian Dynamics and AnyLogic model the behavior of people moving on sidewalks, stairs, and escalators, etc., in stores, stadiums, airports, etc., in both normal and evacuation scenarios. The pedestrians are aware of others, take alternate pathways and obstacles around them. Like in the real world, their behavior is random, including walking at different speeds, going around obstacles in different ways, passing each other, etc. Discrete event tools like plant simulation, Simulate, and AutoMod let you analyze the operation of a line, entire departments, or a whole facility. It's a perfect tool to identify bottlenecks and play what-if games to eliminate them. You can optimize overall items like throughput, buffer sizes, scheduling, and workers. A discrete event simulation is often referred to as throughput simulation. Oh, by the way, our animated title screen for this webinar showed plant simulation in action. Just in case you haven't heard the term virtual commissioning before, our next topic will let you know what in the world virtual commissioning is. So, setup and ramp up of the control system implementation for robotics and automation is called commissioning. Traditionally, this step is built on the shop floor. Virtual commissioning tools let you develop, test, and optimize commissioning early during the planning and design phase in a virtual environment before production starts, before connecting to the real system. It uses highly accurate digital twins of equipment like robots, PLCs, conveyors, light barriers, etc., without any risk to the real facility. There are two major types of virtual commissioning. For software in the loop, a simulation model interacts with a digital twin of hardware like a PLC. This lets the simulation model interact with the exact same programming and behavior in the real world before equipment is installed in the plant. For hardware in the loop, a simulation model interacts with the actual PLCs, again, before they have been installed. Both types help ensure that the control logic used by the model is the same as in the real world. Our next topic discusses the powerful virtual commissioning tools available from Siemens. It's easy to get them confused with one another. Okay, first is SIMET, and that has an interface between various tools. PLCSIM Advanced is a great software in the loop tool that provides a virtual digital twin of an S1500 controller. And here's another nice diagram of how PLCSIM Advanced interacts with the WINCC panel, which is the control panel for equipment. And you can do step 7 programming, upload and download between the PLCs. Now we have simulation tools at every level. You may have wondered where and when the numerous Siemens simulation and virtual commissioning tools are used. At the top, we have the broadest level, production lines and entire plants and facilities. This is where Kinematic's plant simulation, my personal favorite tool, is used, whether in standalone simulations and for virtual commissioning, especially for material handling systems of conveyors with complex control logic, or determining the most efficient number of AGVs, the number of locations of battery charging stations, and charging strategies in order to reach throughput goals. Before we go down to the next level, let's look at a nice short but sweet video courtesy of Siemens showing material handling in a warehouse, including an automated storage and retrieval system, conveyors, robots, and AGVs. As you can see here, plant simulation, I can easily simulate racks in a warehouse, and various types of conveyors can be switched for their 3D representation. And here you see AGVs running along tracks. AGVs in plant sim can also run along freely. I hope that video showed what a powerful tool plant simulation is. Along with virtual commissioning, one level down we have another cool simulation category, robotic cells. Instead of listening to me babbling about it, I thought you'd like to watch and listen to another nice video.
Process Simulate enables engineers to use a 3D environment to design equipment and refine manufacturing processes. Evaluating multiple iterations and problem solving are performed in the office rather than on the shop floor, so engineers can be confident that their designs will meet functional and performance requirements before implementation. Siemens offers an integrated environment that allows critical collaboration between engineering disciplines. Manufacturing engineers working in Process Simulate can share information with controls engineers who are developing Step 7 control logic and HMI design in Siemens TIA portal, a state-of-the-art software technology unifying all automation software tools in a single development environment. Using Process Simulate for robotics and commissioning, engineers can validate their logic test mechanical sequences and safety interlocks and run other system diagnostics. Flexible automation systems often include the use of robotics. Control of these robots must be fully integrated with automation control in the system, and the logic in both the robot programs and PLC must be validated to ensure proper function. These steps are easily accomplished using Process Simulate. At the appropriate point in the development lifecycle, operators from the shop floor can be brought into a hybrid commissioning environment for system training. Here, we utilize appropriate amounts of hardware in the virtual environment, so operators can become familiar with both the automation and processes. This step helps reduce errors that would normally have to be corrected during ramp-up. With innovative technology offered by Siemens, companies can confidently get the right product to market at the right time.
Okay, I can't keep my my need to not gush about these tools. I really think these tools are really cool. Another one is NX Mechatronic Concept Design, which models production machines, is another really cool tool. A functional model provides a common language for mechanical, electrical, and automation disciplines to work together in parallel. MCD allows you to not only see what it looks like, but validate how it works before you build it. This is enabled by the reuse library, from which you can quickly add data to the functional model. This data includes joints, motion sensors, actuators, collision behavior, and other kinematic and dynamic properties for each component. This allows a physics-based interactive simulation to verify machine operation. We have another nice quick video that shows this simulating a packaging machine. Be sure not to miss the physics navigator at the left and the user-friendly sequence editor at the bottom. So again, you can see that the sequences being highlighted as the animation progresses. Okay, it's almost done. SimCenter AmSim is also in this list. It operates at the component physics level. And SIMIT, which operates at the component communication level, which communicates with the hardware like PLCs. And with automation, we have PLCSIM Advanced, which is the digital twin of a S7 controller. That's an extremely powerful tool that handles the software in a loop. There are two major types of virtual commissioning. For software in the loop, a simulation model interacts with a digital twin of hardware like a PLC. This lets the simulation model interact with the exact same programming and behaviors in the real world before equipment is installed in the plant. For hardware in the loop, a simulation model interacts with the actual PLCs, again, before they have been installed. Both types ensure that the control logic used by the model is the same as in the real world. This avoids the problem of a model using different control logic programming. Okay, the problem of a model using different control logic programming can vary from the model still accurately matching the throughput of the real world just by chance to being so far off that it's so wrong that very expensive decisions could be made based on the model. The biggest headache for nerds like me who enjoy building simulation models full of custom programming is that the model might have some garbage in it that could result in much bigger garbage out of it. That's why no matter if you use virtual commissioning or not, you should make sure that the control logic in the simulation matches that of the real world. A few years back, my first virtual commissioning client had this very problem in the past, which was not discovered until the plant was built and didn't meet the throughput goals that the model indicated could be met. And you guessed it, the problem was that the model did not model the same control logic as the PLCs. So they wanted to ensure that they didn't get burned again. Our next topic discusses the powerful virtual commissioning tools available from Siemens. It's easy to get them confused with one another. Siemens tools provide hardware-in-the-loop virtual commissioning through more than one PC to PLC controller communications protocol. For example, Kinematic's plant simulation can communicate directly to controllers via the OPC Classic or OPC UA protocols. Those are open protocols. PLCSIM Advanced is a powerful digital twin of an S7 1500 hardware controller that provides software-in-the-loop virtual commissioning. Note that several instances of PLCSIM Advanced can be made on your computer to provide digital twins of more than one controller. WINCC has great tools for the configuration of somatic HMI, the human interface operator panels. We have another video that shows you this cool tool. So again, this is focusing on the panel, the operator panel. You can probably tell from that video that that tool allows people to design an operator panel in a fraction of the time, and then when you update to a different type of panel, it's very easy to just have it automatically adjust to the new panel. SIMIT is a simulation platform that is capable of comprehensive automation, project testing, and process commissioning, all in one platform. It can also be used as a training tool to teach operators and maintenance how to efficiently run their plant. SIMIT can communicate with hardware, PLCSIM Advanced, and NX MCD, process simulate, and plant simulation. Note, SIMIT lets you easily switch between software-in-the-loop commissioning using PLCSIM Advanced and hardware-in-the-loop using SIMIT units, all in one place. The TIA, Totally Integrated Automation Portal, reminds me of a shopping mall that carries nearly everything. TIA brings nearly everything except for the kitchen sink and one interface, from digital planning to integrated engineering and transparent operation, including simulation tools. From field level right on up to the cloud, the TIA Totally Integrated Architectural portal seamlessly connects a comprehensive array of hardware, software, and services tools in several categories. It's an open system architecture that allows integration of new technology, so it's constantly being updated. Now, before we end, let's look at the numerous benefits of virtual commissioning, which does have several benefits. One of the top ones there, debug and validate PLC programming virtually. That's a huge advantage. So it results in a reduced time to job one by around 30 to 60%. It reduces costs, reduce unpredictable situations like robots colliding, no impact on running production. The model logic matches the real world. We already talked about that problem. And a nice side benefit, train users before real systems exists. Another powerful thing is to have offline programming capabilities. And you saw the WINCC making user-friendly HMI layouts. And finally, a great sales tool.